I've been seeing a lot of other posts, so I'm just like, you guys have been seeing it? Because I'm not sure if you guys have been taking advantage of it, but... Oh, we're starting. Okay. Alright. Off on a tangent. And, yeah. Cool. Alright. So any questions on anything? Okay. Alright. So, just a few quick announcements. So quiz 3 covers lessons 7 and 8. And your window is going to be from Monday at 9 a.m. to Tuesday at 9 a.m. of next week. And because I haven't really had a chance to think about a good extra credit opportunity, I'm just going to pull a semi-lazy route and just say, as long as you take quiz 2, then you get 2 extra credit points. That's your extra credit opportunity for this part of the course. So even if you do really well on it, even if you do really poorly, even if you don't complete it at all, as long as you at least start the quiz, then I will count that as you getting 2 extra credit points right after that. So that's a little something to look forward to. And then exam 1, so it's going to cover lessons 2 through 10. And then it's going to be, the window is going to be from Thursday of next week on the 17th to Sunday the 20th. So it starts at 9 a.m. on Thursday and then ends on 9 a.m. on Sunday. And in this case, you have 60 minutes to complete the exam unless you have a DRC accommodation that says otherwise. So, all right. So any questions on that? All right. All right. So let's start by talking about the product rule. So let's do this. Just make my desk space a little cleaner. All right. So product rule. So let's first recall the derivative rules that we know so far. So in this case, we're going to go ahead and let this value c, we're going to let that denote a constant. Constant. So we have c for a constant, then the derivative of that constant, well, that's equal to 0. And then the next one is the power rule, which states that the derivative of x to the n is n times x to the n minus 1. So you guys recall this is what's known as the power rule. Okay. And then the next one is you have a constant times a function we know how to differentiate. Well, that's the same thing as just take the constant x. C times d over dx of f of x. Okay. So then the next one is d over dx of f of x plus or minus g of x. That equals, well, so the derivative of a sum/difference of 2 functions is the sum/difference of those 2 derivatives. So namely, you have derivative of f plus or minus derivative of g. Okay. And so the nice thing with this part right here is that this says that this lets us differentiate term by term. Okay. So if you have a sum/difference of a bunch of functions of x, then you can just focus on the derivative of each of those terms individually and then add/subtract as necessary. Okay. And then the derivative of some more explicit functions. Sine, the derivative of that is going to be cosine. Derivative of cosine is negative sine And then the derivative of e to the x is just e to the x. Okay. So that's all the rules that we know so far, just from lesson 7. So while that's good and all, unfortunately, this is definitely not an exhaustive list, because you could have the case where, say, even though you have a sum/difference of two functions, well, in a lot of cases, you're going to end up having the case where, you may have a product of them, for instance. So in the event that happens, well, that's where you're going to need product rule to come into play here. So if you want to find the product of a product of two functions and you want to take the derivative of a product of two functions, then this is the same thing as saying, well, f of x times g of x prime. That's just a different way of saying the same thing in this particular case. So here's what the product rule says. So we have f prime of x times g of x plus f of x times g prime of x. So that's what the product rule ultimately says here. Okay. But here's the nice thing. We have an addition sign here, right? So that means because of that, you can basically just switch the order of these two terms, and it would not affect the product rule at all. So what I mean by that is I can just as easily say this is just f of x times g prime of x plus f prime of x times g of x. Okay? So the good news is that this says that order is irrelevant in this particular case. So as long as you're multiplying one function times the derivative of the other function and then adding the derivative of the first function times the original second function, then that's all you need to know for product rule. So, okay. So any questions on that? Okay. So let's go ahead and apply this to a specific example here. So example 2. It says this. So we have to find the derivative of h of x equals 1 plus x squared times 2 minus x cubed. So the nice thing is there's a couple of ways we can attack this. But before we get into that, let's go ahead and rewrite our function so that way it's a little bit easier to work with in terms of finding derivatives. So in this case, we have, all right, well, 1 plus x squared for the first part. There's nothing too much we can say past that. But then we have 2 minus, we have the square root of x cubed, which is the same thing as x to the what power? 3 halves, right? Okay. So taking that into account, let's go ahead and work with this. So the first way says, okay, so let's suppose we didn't know what the product rule was. We only have these tools at our disposal here. What do? Well, the best thing we can do, or I guess the only thing we can do in this case, is say, all right, well, method one, just expand h of x and differentiate as in lesson 7. Okay. So here's what I mean by that. So h of x, if we have 1 plus x squared times 2 minus x to the 3 halves, then if we were to expand that out using the FOIL method, then what should we end up with as our other way of expressing h of x here? So foiling out h of x as it currently is expressed here should give us what? Raise your hand if you have it. Okay, so we have, 2 plus x squared. So what was the second term again?
2 minus the square root of x cubed.
So that's the same thing as x to the 3 halves. And then plus 2x squared, and then minus what?
X squared times the square root of x cubed.
Which simplifies to x to the what power?
X to the x cubed. X to the 7 halves.
Right, so 7 halves, because you're saying, okay, if you have x squared times x to the 3 halves, you have to add the powers to get 2 plus 3 halves for your power, which then simplifies to 7 halves. Okay? Alright, so now, if we have that, we say, alright, the derivative then becomes what? The derivative of, well, 2 minus x to the 3 halves plus 2x squared minus x to the 7 halves. Okay? So applying power rule on all this gives you what? Right. Okay, so let's go over why that is. So we have, if we break this up into each of its individual terms, so we have derivative of 2 minus the derivative of x to the 3 halves, and plus, well, we have a 2 out here, but we can just take that out of the derivative to get 2 times the derivative of just x squared, then minus derivative of x to the 7 halves. Okay? So taking the derivative of each of these yields, well, this is just a big fat 0, so we can ignore that. Then minus derivative of x to the 3 halves, so that's 3 halves x to the 1 half. Then plus 2 times derivative of x squared, so 2x. So multiply 2, you get 4x. And then minus 7 halves x to the 5 halves. Okay? So that would be your derivative in that case. Okay. So any questions on that? Okay. So that's one way to get it, but the other way says, all right, now that we know product rule, let's go ahead and use that here. So in this case, we say, all right, well, method 2 method 2 use product rule. Okay. So again, I'm going to rewrite h of x as the product of these two functions as we have here. So we have 1 plus x squared times 2 minus x to the 3 halves. Okay. So in this case, if we want to view this as the product of two functions of x, we can. So what we would do here is say, all right, well, the first part will be our f of x, our 1 plus x squared. And then g of x will be the second thing. So g of x would be 2 minus x to the 3 halves. Okay. So let me just do this. There we go. Okay. So if that's the case, that says, all right, well, now what we're going to do from this is we're going to draw sort of a little roadmap in some sense. So we have f of x equals 1 plus x squared, and g of x equals 2 minus x to the 3 halves. Okay? So doing this will give us, well, f prime of x and g prime of x. So now we have to differentiate each of these to be able to apply product rule because, well, if we take a look at product rule, well, we do need f prime and g prime here. So if f of x equals 1 plus x squared, then f prime should be 2x, good, and g prime is going to be negative 3 halves, x to the 1 half. All right? So now that we have that, let's go ahead and apply this, plug this into product rule. So we have h prime of x equals, well, we have, actually I'm going to black code this. So we have h prime of x equals, well, 1 plus x squared, because this part is just f of x, then times g prime of x, which is negative 3 halves x to the 1 half, so that's g prime, and then plus, well, g, which is 2 minus x to the 3 halves, so g of x, times f prime, so 2x. So f prime of x. Okay. All right, so now that we have all that, let's go ahead and distribute everything out to make sure we're consistent with what we had before. So in this case, if we distribute g prime of x into both terms of f of x, well, we should have negative 3 halves times x to the 1 half, then minus 3 halves times x to the what power? Go ahead. 5 halves, good. So that's that part. And then plus, well, then we do the same thing with distributing f prime into g of x. So in this case, we should have 4x, just distribute that into 2, and then minus 2 times x to the what power? Someone else? X to the what power? Well, 3 halves times x, but you have to multiply x into that. So you're essentially adding 1 to that. So it'd be 3 halves plus 1, which is 5 halves. There we go. Right, so yeah, 3 halves plus 1. And you can think of this as like 3 halves plus 2 over 2. And that's how you get 5 halves. Okay. So then now we just condense everything down. So we have, well, the only 2 common terms are the ones involving x to the 5 halves. So we have negative 3 halves times x to the 1 half minus 7 halves x to the 5 halves plus 4x. So that's one way to check that your answer should be consistent with the one found in the first method. So both methods should yield you the same thing here. So okay. Any questions on that? Okay. So here's the thing with this. So the thing is that product rule may not be, the easiest, quickest, or cleanest way to help you find the derivative, but as we'll see later on, sometimes you may not get a choice. So product rule may not be the easiest, quickest, cleanest way to find derivative, but, well, sometimes product rule is your only option. So, but, as we'll see in example 2, we may not get a choice. Okay? Alright. So to see why, let's take a look at example 2 then. So we're given that y equals 3 times e to the x times sine of x minus 9 times e to the x times cosine of x. So we have to find the derivative evaluated at pi over 4. Okay? Now the thing is that what you could do, and this isn't wrong, this is not wrong, but you could just, take the derivative of 3 times e to the x times sine x, and then do the same thing with e to the x times cosine of x. Here's the thing though. Basically means you're going to have to do product rule multiple times here. So to condense down computations a little bit here, what we notice is that, well, both terms seem to share some common factors, right? So in this case, if we were to factor out, say, so if we were to factor out something, then this can make things a bit easier. So what can we factor out of y here to make things a little bit easier on our end?
3e to the x.
Yep, 3e to the x, right? So we have sine of x, 3e to the x times the quantity sine of x minus 3 cosine of x. Right? And the reason we're doing that here is because, well, so factor out 3 times e to the x to condense computations. Okay. So that'll make things a little bit easier on our ends. Okay? So in this case, we say, all right, now let's go ahead and find the derivative of this. So, in this case, if we want to find the derivative, well, we have one function of x times another function of x, so we got to apply product rule. I think those two mixed up a lot lately. Oops. Oh, yeah, so in this case, our f and g would then be what? So if we break it up into these two functions, well, f of x should be go ahead. Yep, 3e to the x. And then g of x should then be the rest of it, right? So we have sine of x minus 3 times cosine of x. So in this case, we say, all right, well, we need our corresponding derivatives. So let's go ahead and find them. So, well, f prime should be, in this case, f prime will just be 3 times e to the x, because derivative of e to the x is itself. But then g prime of x will be what? Yep. Yeah, so cosine of x plus 3 times sine of x. Okay? So using this little roadmap here, so we have, that tells us that y prime is equal to, well, f times g prime, so 3 times e to the x, times cosine of x, plus 3 times sine of x, and then you have f prime times g, so plus 3 times e to the x, times sine of x minus 3 times cosine of x. Okay? So the nice thing is that while this application of product rule is not wrong, and this actually does give you the correct answer, what we're going to do is we're going to simplify this as much as we can, because there's a lot of things we can simplify here. So what we notice is that, again, both terms in our expression for y prime, again, have 3 times e to the x in it. So let's again factor that out. So factor out 3 times e to the x. So we do that. We have 3 times e to the x times, well, so we have cosine of x plus 3 times sine of x. And then in this case, well, and then plus sine of x minus 3 times cosine of x. All right? Okay, so now that we have that, we can say, all right, we have 3 times e to the x, and then if we simplify this expression inside the parentheses as much as we can, then that should give us what? Go ahead.
4 sine of x minus 2 cosine of x.
Yep. 4 sine of x minus 2 times cosine of x. Okay. And again, this is a lot more simplified, but because both terms in here have a common factor of 2, let's go ahead and factor that out as well. So we're ultimately left with 6 times e to the x times 2 times sine of x minus cosine of x. So this will ultimately correspond to our derivative here. Okay. So any questions on that part before we move on to the next bit of example 2? Okay. So the nice thing is that while we do have our derivative, well, that's not quite what the question wants us to find. Because we're trying to find, well, y prime of pi over 4. So what that says is that, well, we just got to let x equal pi over 4 now. So that implies, well, y prime of pi over 4 is then equal to, well, 6 times e to the pi over 4. So 2 times sine of pi over 4 minus cosine of pi over 4. So in this case, because we have to deal with sine of and cosine of pi over 4, we got to harken back to our good old unit circle here. So unit circle. So with 6 times e to the pi over 4, well, there's not really much we can do with that, so let's just leave that alone. So now we have 2 times, well, sine of pi over 4, which is sine of pi over 4 is
negative 1/2?
not quite, because remember, pi over, what's that?
No 1/2 then?
No, I think you're thinking of some at another angle.
Is it 1 over 2?
Right. So in this case, you could have root 2 over 2. Okay. And then minus cosine of pi over 4, which is cosine of pi over 4 is going to be what value?
Root 2.
Yep, it's also root 2 over 2. Good. So in this case, we say, all right, well, we have 6 times e to the pi over 4. And then, well, we have 2 times root 2 over 2 minus root 2 over 2. So we can just write that as just root 2 over 2. And the nice thing is that, well, we have 6 divided by 2, so we can cancel that out to just get 3 times e to the pi over 4 times the square root of 2. So this will be our final answer that we need here. Okay, so that is example 2. So any questions on that? Okay. Okay. So I'll give you guys a second to write all that down. And then we'll move on to example 3. So in this case, we have to find the x values at which y equals negative x to the 4th times e to the x has a horizontal tangent. So let's quickly review our little discussion from last time. So our horizontal tangent line says, all right, so if we have just a horizontal line, then the horizontal tangent line is going to give us something like this. Okay? So if we recall from last time, a horizontal tangent line has slope equal to what? What do we say about the tangent, the slope of a horizontal line?
It's 0.
Yeah, just big fat 0, right? So what does that tell us about what we need to find? So that says, all right, remember the slope of a tangent line is the exact same thing as what? From, if you recall from last Friday. Slope of the tangent line is the what? Go ahead. Yeah, it's just the derivative, right? So that means that if you want to find where there's a horizontal tangent line, you just have to take your derivative and set it equal to 0, right? So find x values for which y prime equals 0. Okay? So in this case, well, if you want to find the derivative of our function here, so we again have a product of two functions here. So how would you want to break this up? So what would your f of x be here, and what would your g of x be here? If you want to break this up using the product rule.
F is negative x to the fourth.
Yep, negative x to the fourth, and g of x would just be whatever is left, right? So that would give you your decomposition for product rule. So this would be f of x, and this would be your g of x. Okay. So let's see. So the derivative of g is just e to the x, as we have been discussing. But then f prime of x would have derivative what?
Would it just be negative 4x cubed?
Yep, negative 4x cubed, right? So, if that's the case, that says, all right, well, y prime then, as in applying the product rule, will give us negative x to the fourth times e to the x plus e to the x times negative 4x cubed. So, or put another way, negative x to the fourth, e to the x, minus 4x cubed, e to the x. So now that we set this equal to 0 because of our discussion here on the second line, now let's go ahead and find the values of x that give us this equality here. Okay? So by itself, this looks kind of like, this looks a little weird to try and work with on its own. So it might help to try and condense things down a bit. So what can we factor out of both terms, if applicable, to make things look a little bit better for us?
Negative x cubed e to the x?
Yep, we can factor out negative x cubed and e to the x. So we're just left with x plus 4 equals 0. So then from this, what values of x give us that this equality holds? Let's give someone else a chance. Just that. Go ahead.
Would it be x equals negative 4?
Yep, that's one of them. And the other one is? Well, we have x cubed here, right? So what should that tell us about the second one? So what happens if we let x equal 0 here? Okay. So if we let x equal 0, right? Well, then we just have 0 right away from x cubed, right? So that gives us another x value. That gives us the desired equality. Okay. And in this case, those would be your only two values, right? Because e to the x, well, that's never 0, so you can ignore that in the context of the equality we're trying to solve for. So in this case, then that's our answer, and that's it for example 3. Okay. Any questions on example 3 then? So now, let's move on to the last problem. So in this case, it's going to be everyone's favorite problem of finding the equation of the tangent line. So we have find the equation of the tangent line to 12x squared times cosine of x at x equals pi. All right? So as usual, we're going to need to break this down into our usual 3 steps. Step 1 is find the slope of tangent line. Okay. So in this case, i.e., we have to find what value? So we have to find what?
Derivative.
Derivative and evaluate it at.
X equals pi.
So in this case, we just have to find y prime at pi. Okay. So we have y equals, well, 12x squared times cosine of x. In this case, well, we again have a product of two functions of x. So we have to break this up for our product rule. So what would our f and g equal here?
F be 12x squared and then G be cos or whatever's left.
Yep. So in this case, f of x is our 12x squared, and g of x is whatever's left. So in this case, cosine of x. Okay. So that implies, well, g prime of x is just, well, negative sine of x, and f prime of x would then equal what? 24x. So that's applying the power rule. So then we can then get that the product rule yields that the derivative is ultimately, well, f times g prime. So in this case, negative 12x squared times sine of x plus, well, f prime times g, so 24x times cosine of x. So that's our derivative, so nothing too crazy with that. But as we mentioned, we need to let x equal pi from this. So if we do that, we have negative 12 times pi squared times sine of pi plus 24 pi times cosine of pi. Okay? So if we were to simplify this expression using stuff from the unit circle, what should we then get as our slope? Let's give someone else a chance. Okay. So, what would our slope be for this? If we simplify this as much as we can. First off, well, let's take a look at our unit circle here. So sine of pi is equal to go ahead. 0. So this just goes away. And then cosine of pi is negative 1. So we have negative 24 pi is then ultimately our slope here. Okay? So that's step 1. So now let's go ahead and move on to step 2 from this. So step 2, find points on tangent. Okay? So the good news is that as we have established, all we really need to do is just take our x value and just plug it straight back into our function here. So if x equals pi, then that implies that y is going to equal, well, 12 pi squared times cosine of pi. But as we already established, cosine of pi is just, well, negative 12 pi squared. Oh, sorry, cosine of pi is negative 1, so that gives us negative 12 pi squared. So then that means the points on the line is just pi comma negative 12 pi squared. Okay? Okay, so that takes care of step 2. Nothing crazy with that. So now step 3 is just put everything together. So then find the equation of the tangent. So again, use point slope form. Okay. So if we use a point slope form, given that our slope is this, negative 24 pi, and our point on the line is equal to pi comma negative 12 pi squared, if we put everything in the point slope form, what should we end up with as our line? So here I'm just focusing more on what exactly you get if you just plug everything directly into the point slope form. Like what should you immediately get?
The equation would be y plus 12 pi squared
Yep.
equals negative 24 pi multiplied by the quantity of x minus pi.
Correct. Okay. So then, actually, I'm just going to rewrite this a tiny bit, but yeah, that is correct. But I'm just going to rewrite this just a little bit. So we have y minus negative 12 pi squared. So yeah, because if you remember, this is just y minus the y coordinate of your given point equals the slope times x minus the given x coordinates. So, all right. So then, from that you have y plus 12 pi squared equals then, you distribute negative 24 pi into the expression, you get negative 24 pi x, in this case, plus 24 pi squared, just distributing everything in on the right-hand side. So then you ultimately get that the point slope form is then going to be, well, negative 24 pi x, and then plus what? So what's the last term going to be if we bring this 12 pi squared over to the other side? Yep, just 12 pi squared. Okay. And that, ladies and gentlemen, is your equation of the tangent line. So any questions on that? Alright. Then I will go ahead and see you guys on Monday. Have a good weekend. Stay safe. And yeah. If you have any questions, let me know. And yeah, that's about it. Otherwise, have a good weekend.